learners, welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we will be focusing on mechanics, which has a total of 93 marks. And today's topic will be focusing on momentum, which is question 3, and it consists of plus minus 21 marks. So for the mark allocation for paper 1, we have section A, which consists of 10 multiple choice questions and has 20 marks. Then you'll either have 8 matching items or 1 word items that has 8 marks. Then you'll have section B, which consists of structured or long questions and has a total of 122 marks. So now for the total of the mark allocation for paper 1, you'll have 150 marks with a duration of 3 hours. The topics to be covered in paper 1 will be under mechanics, which has a total of 93 marks and has a percentage weighting of 62. Electricity and magnetism, which has a total of 33 marks and a percentage weighting of 22. Wave, sound and light, which has a total of 24 marks and a percentage weighting of 16. So now under momentum and impulse, we have covered the following. We have covered the definition, we have covered the formula, we have covered the relationship in terms of momentum, we have covered the change in momentum, the formulas of the change in momentum, the law of conservation of linear momentum, Newton's second law in terms of linear momentum and its formula. We have covered impulse, and we have also covered the types of collisions, which is elastic and inelastic collision. So this is basically a summary in terms of momentum and impulse. So now for you to do your questions, you are going to need your formula sheet, and you need to be able to identify the correct formulas that you need to use. So for momentum, we are going to be using this formula, which is P is equals to mv. Then we are going to be using this formula, that is F net change in time is equals to the change in the momentum. Then we are also going to use this one here, which is the change in momentum is equals to mv final minus mv initial. So it is very, very important that you have a formula sheet, so that even when you are doing your homeworks or even when you are practicing, you are able to refer to your formula sheet. Then in terms of momentum, this is what we have covered. We said that you need to be able to define momentum, and you need to be able to define momentum according to the examination guidelines. So it says momentum, define momentum as the product of an object's mass and its velocity. So we said when we talk about the product, then we are talking about the multiplication of what? Of the mass and the velocity. Then we said linear momentum is a vector quantity. So by the word linear, we said it means momentum on a straight line. So it says linear momentum is a vector quantity with the same direction as the velocity of the object. For a vector quantity, we said it's a physical quantity which has both magnitude and direction. And we said, what is magnitude? Magnitude is the size. So meaning that for an answer of momentum, we are going to have magnitude, which is the size. we are going to have the SI unit, and then again we are going to have what? The direction. So the statement here says linear momentum is a vector quantity with the same direction as the velocity of the object. So it means that according to this formula, P is equals to mv. The direction of this momentum P, where are you going to get that direction? You are going to get it from the velocity. Why the velocity? Because it says that it is a vector quantity that will have the same direction as the what? As the object's velocity. So it will have the same direction as that velocity there. And then we spoke about the SI units of momentum. We said the SI units of momentum will come from what? Will come from the mass, which is what? Kilograms, and from the velocity, which is meters per second. So the combination of the two will then give us the units of momentum, which is then what? Kilograms meters per second. Then we spoke about the relationship between the mass and the momentum, and then we said that both the mass and the velocity are directly proportional to the what? To the momentum, meaning that as the mass increases, the momentum will also what? The momentum will also increase. And then again, as the velocity increases, the momentum will also increase. So the relationship between the mass and the momentum is that they're directly proportional, and the relationship between the velocity and the momentum is also that they're directly proportional, meaning that as one increases, the other one will increase, or as one decreases, the other one will also decrease. Then we spoke about the change in momentum, and then we said it is the difference between the final momentum and the initial momentum. So change in momentum is represented by what? Is represented by the change in P. And then we said what? The change in momentum is the difference between what? The final momentum and the initial momentum. And then it says here, it depends on the change in what? On the change in the velocity. Then again, the SI units of the change in momentum are also what? Kilograms meters per second. So what you need to take note of is that the SI units of the change in momentum and the SI units of momentum are exactly the same. So they are both what? Kilograms meters per second. Then it says here change in momentum would be the mass and the final velocity minus what? Minus the initial velocity. Okay. Then with the impulse, you need to be able to define the impulse as the product of the net force. So the product of the net force acting on an object and the time the net force acts on the object. So again, product, it means that it has to do with the multiplication. So right now it's the multiplication of the net force and the what? And the time the net force is acting on the object. That is impulse. So impulse is given by F net, change in time. Then we said impulse is equal to the change in what? To the change in momentum. So it's F net, change in time, is equals to the change in what? The change in momentum. Then it says use the impulse momentum theory, whereby the impulse is equals to what? To the change in momentum. Then again, we need to remember that impulse is a vector quantity and its SI unit is what? Is Newton second. So where do the SI units come from? Remember, F net is a force. So the SI units of F net would be what? Would be Newton. and then the change in time, the SI unit is what? The SI unit would therefore be second. So Newton second, not Newton per second. Okay. Then it says, note that when calculating the change in momentum, the SI units would be those of momentum. So whenever you are going to calculate the change in momentum, which is this one here, so change in P, or this one here, whenever you are going to calculate the change in momentum, the SI units would be those of momentum. And what are the SI units of momentum? The SI units of momentum is kilograms meters per second. Then it says an impulse will have the same value as the object's change in momentum, but with a different SI unit. So if you were to calculate the change in momentum, or if you were to use values to calculate the change in momentum, and the question is asking you to calculate the impulse, it says here that impulse will have the same value. So let's say that you have used the values of change in momentum, and let's say, for example, your answer is there for 40. We are saying that the impulse will have the same value, so meaning the very same 40. The very same 40 would be the same value of impulse, but you will have different SI units. Okay, so instead of you having the SI units of the change in momentum, which is kilograms meters per second, you are going to have the very same SI units. You are going to have the very same SI units of what? Of the impulse. So what are the units of impulse? It is going to be Newton second. Okay, so I'm going to repeat that for the last time. It says that impulse will have the same value as the object's change in momentum. So if you had calculated the change in momentum and your answer was 40, you are not going to use the units of the change in momentum, because the question would be asking for you to calculate the what? The impulse. So in terms of the units, you are going to be using Newton second, because that is the units of what? Of impulse. Then we spoke about the application of momentum, impulse, and the change in momentum. So using this formula, F net is equals to change in P over change in time there. It says here the net force is inversely proportional to the change in time, that is for the same change in momentum. Okay, let us read again. The net force, so which net force? This net force is inversely proportional to the change in time, and that is for the same change in what? In momentum. Okay, so meaning that if the net force increases, then the change in time would do what? The change in time would decrease. That is for the same change in what? In momentum. Again, what does it mean? It also means that if the net force, or if the change in time increases, then net force would do what? Would decrease. So remember, we spoke about these applications. We spoke about the front crumple zone. So we said the crumple zone would be represented by the front of a car. So we said that if a car was to be involved in an accident and then it has a crumple zone, what is going to happen? So the more time the car takes to crumple, then we are saying that there would be an increase in the so the time of contact would increase. If the time of contact increases, that means that the net force will do what? Will decrease. So if the time of contact increases over here, it means that the net force will do what? The net force would decrease. And then if the net force decreases, that will reduce the what? That will reduce the injuries that are going to happen to the passenger. Then again, if we spoke about the airbags, and then we said that if there is an airbag in the car, and let's say that the car was to be involved in a crash, then what is the airbag going to do? The airbag would increase the time of contact. So if the airbag increases the time of contact, what is going to happen? The net force will do what? The net force will decrease, and that will reduce the injuries. But we must also not forget this statement to say that for the same change in what? For the same change in momentum. Okay? Then we also spoke about the seat belts, and then we said that what do the seat belts do? So if you have a seat belt on, and again the car was to be involved in an accident there, the seat belt would increase the time of what? Of contact. So if the seat belt increases the time of contact, then the net force will do what? The net force will decrease. If the net force decreases, that will reduce the injuries, and that is for what? For the same change in what? In momentum. Then again, we spoke about the arrestor beds. So we said arrestor beds would normally be represented by, so that is just a gravel or sand that you find on the side of the highway. So it is normally there in case if maybe the truck loses control, or maybe the truck's brakes fail, then the truck would then drive into that gravel road. And then when the truck drives into the gravel road, what is going to happen? That would then increase the time of contact. So if the time of contact increases, what happens to the net force? The net force would therefore decrease. And if the net force decreases, that will reduce what? That will reduce the injuries on the passenger who is in the truck. And that is for what? That is for the same change in momentum. So that is how you would answer this question, which is usually about 3 marks or so. So you would have to mention that, you would have to mention a decrease or an increase in terms of time. You would have to mention a decrease or an increase in terms of the net force. And then you would have to mention an increase or a decrease in terms of the injuries. But this one will therefore stay the same, which is for the same change in what? In momentum. So remember, you will use this formula. This formula will assist you. And how is it going to assist you? You need to know the relationship between F net and the change in momentum. And what is the relationship between F net and the change in momentum? They are inversely proportional. That means that as the change in time increases, the F net will do what? Will decrease. Or as the F net increases, the change in time will what? Will decrease. That is for the same change in what? For the same change in momentum. Then we spoke about the conservation of linear momentum. So you need to explain what is meant by an isolated system in physics. And then it says an isolated system is one on which the net external force acting on the system is what? Is zero. So remember when we spoke about the net external force, we said an example would be your friction, another example would be your tension. Then it says you state the principle of conservation of linear momentum, which says the total linear momentum of an isolated system remains constant or is conserved in what? In magnitude and what? And in direction. So from there, you need to know how to use this formula of the total momentum before, or you can also write it as the sum of the initial momentum is equals to the sum of the final momentum. So from there, you will then say the total momentum before is equals to the total momentum after. So this is then MAVA, that is for object A, MBVB for object B. Then again, the total momentum after. So the MAVA would be representing the total momentum after, and then the MBVB would be the momentum of B after the collision. Then we spoke about elastic and inelastic collision. And then for an elastic collision, we said a collision where the total kinetic energy remains constant. So total kinetic energy remains constant, and the total momentum and the total kinetic energy are what? Are conserved. So you need to be able to remember the following information. The total momentum, so meaning the total momentum before collision would be the same or equal as the total momentum after the collision. And again, it says the total kinetic energy are what? Are conserved. So again, meaning the total kinetic energy before the collision would be equal to what? To the total kinetic energy after the collision. Then for an inelastic collision, it says a collision where the total kinetic energy is not conserved and the total momentum is what? Is conserved. So for this one, it says the total momentum is what? Is conserved, meaning the total momentum, so meaning the total momentum, the sum of the total momentum before the collision is equal to the sum of the momentum after the what? After the collision. But in terms of the kinetic energies, it says the sum of the kinetic energy before the collision, it says, is not equal to the sum of the kinetic energy, so is not equal to the sum of the kinetic energy after the collision. And then this one, the sum of the momentum before the collision is equal to the sum of the momentum after the collision, but the sum of the kinetic energy before the collision is equal to the sum of the kinetic energy after the collision. So what is the difference between these two then? The difference would be the kinetic energy. For an inelastic collision, the sum of the kinetic energy is equal to the sum of the kinetic energy after the collision. But for an inelastic collision, the sum of the kinetic energy before the collision is not equal to the sum of the kinetic energy after the collision. And then what is the same between these two? The sum of the momentum before the collision is equal to the sum of the momentum after the collision for both what? Elastic and inelastic collision. So you need to know how to use this formula here, which comes from where? The sum of the EK initial or before is equals to the sum of the EK, the sum of the EK after the collision. Okay, so from there, the total kinetic energy before would be equal to what? Half MV, half MAV 2 squared. So that is for object what? For object A, and then half mv squared, that is for object B. That is before the collision, and then this one, total kinetic energy after. So the first part, half mv squared, would be representing object A again, and then this part again would be representing what? Would be representing object B. So linear momentum and impulse tips. You need to read the scenario carefully and underline the keywords or collect the given data there. And then again, you need to remember that the velocity, the momentum, the change in momentum, and the average force are all what? They are all vectors. And we said, what is a vector? A vector is a physical quantity which has both magnitude and what? And direction. Then it says always take the direction into what? Into account. Okay, for what? For vectors then. Refer to the data sheet when carrying out the calculations, and then you need to pay attention to what? Pay attention to the mark allocation. So now let us have a look at this activity here. 3.1, it says, in the diagram below, an air rifle pellet of mass 2 grams, okay, is fired into a stationary block of clay which has a mass of 56 grams, okay. So we can collect the data as we are reading. What is it that we have? We have a mass of 2 grams. And then it says it says what? An air rifle pellet of mass 2 grams is fired into a stationary block of clay. So this block of clay, it was stationary. So if it's stationary, it means that it had a velocity of what? Of 0 meters per second. And then this clay had a mass of 56 grams. So the picture is illustrating to us that this is before what? This is before the collision. Then it says the pellet strikes the block at a speed of what? Of 140 meters per second to the what? To the right. So we also have the velocity here. We also have the initial velocity of what? Of the pellet. And then we also have the direction. It says it is moving in which direction? It is moving to the right. So 3.1.1 there says we need to define the term isolated system, and that is for what? For 2 marks there. So the definition here says a system on which the net external force acting on the system is what? Is 0. So remember, with the definitions, you need to state them as they are on your examination guidelines. Okay, then it says upon impact the pellet remains inside the block. So we can see the pellet here, it has remained inside the block. So the pellet remains inside the block and they move together as a single unit. And then it says you need to ignore the effects of what? Ignore the effects of friction. Now 3.1.2 says, will the total linear momentum of the block bullet system change after the what? After the collision? Then it says write down only yes or no. So our answer there for 3.1.2 would be what? Would be no, because remember we said that the total linear momentum would be what? Would be conserved. So that is why our change, that is why our total linear momentum would not what? Would not change after the what? After the collision. So then 3.1.3 says calculate the velocity of the block bullet system after the impact. So how are we going to solve this one? We are going to need to collect the data. So remember, we were given 2 grams. So the first thing that you are going to do is that you are going to convert your grams. You are going to convert your grams to kilograms. So when you convert your grams to kilograms, it's either you are going to say 2 divided by what? 2 divided by 1,000, or you are going to say 2 times 10 to the power of what? Of -3, and that would therefore give you your answer in what? In kilograms. And then again, you were given what? 56 grams. So again, you are going to divide the 56 by 1,000, or multiply by 10 to the power of -3, and that would also give you your answer in what? In kilograms. So from there, we were given an initial velocity of the pellet as 140 meters per second. Then we were told that the block was stationary. So if the block is stationary, it means that the velocity would be what? The velocity would be 0. Then for it said that the block and the bullet were then stuck together after the collision. Okay. So now the question here says that calculate the velocity of the block bullet system after what? After impact, or after what? Or after the collision. Okay. So remember that the bullet was moving in which direction? Was moving to the right. So therefore, we are going to take right as what? Right as positive. If right is positive, it means that left would therefore be what? Would therefore be negative. So then, so when you start your calculation, remember you need to start with what? You need to start with the formula. So that would be the sum of the momentum before the collision is equal to the sum of the momentum after the collision. So from there, what do you have? Your initial mass of the bullet was what? Was 2 times 10 to the power of -3. And then your initial velocity was 140 meters per second. In which direction? We said it is going to be to the right. And then from there, the mass of object B, which is the block, was 56 times 10 to the power of -3. But the velocity, the initial velocity, was then what? Was then 0. So if you then have m2v2i, we are saying that the mass was 56 times 10 to the power of -3, multiply by what? Multiply by the initial velocity, which was 0. So therefore, the mass multiplied by the velocity of 0 would therefore give you what? Would therefore give you a 0. So now, after the collision, the block and the bullet were therefore combined, that is after impact. And what are you going to do with the masses? Remember, we had 2 grams and what? And 56 grams, and then we said that we had converted them to what? To kilograms. So we would therefore say the 2 plus by the 56, that would then give us what? 58 times 10 to the power of -3 what? Kilograms. So again, because the 2 are going to combine after collision, so therefore it means that they would only be having one what? One final velocity. So maybe just to elaborate this one, you would have the mass of object 1 plus by the mass of object 2 combined, and you'd also have your what? Your final velocity there. So from there, you would then multiply the left-hand side, and you would therefore divide your answer by what? By the 58 times 10 to the power of -3, and that would give you your what? That would give you your velocity. So remember, velocity is a vector. That means that you need to have what? Magnitude. Magnitude is what? You need to have an answer. And then from there you need to have an SI unit. So the correct SI unit of velocity is what? Is meters per second there. And then you are also going to have direction, which is what? Which is to the right. So remember we said that the bullet was initially traveling in which direction? It was initially traveling to the right. So that is why we are going to take a positive answer as what? A positive answer as positive, and a positive answer as being in which direction? To the right. Okay. So 3.2 now says, during a safety test, a car of mass 800 kilograms, a car of mass 800 kilograms traveling at 20 meters per second east, it says it hits a brick wall and comes to what? And comes to a stop. Okay. So what is it that we have there? We have mass of what? Of 800 kilograms. And then it says traveling at what? Traveling at 20 meters per second. So that would be representing our what? Our initial velocity in which direction? East. And then it hits a brick wall and then comes to what? And then comes to a stop. So if it comes to a stop, that is a key word there. If it comes to a stop, it means that the final velocity is what? The final velocity is what? Is 0 meters per second. Then it says to bring the car to a stop, the wall exerts a force of 1,6 times 10 to the power of 3 there on the what? On the car. So it means that we have a net force of what? Of negative 1,6 times 10 to the power of 3 what? Newton. Because initially what was happening, the car was hitting the wall and then it came to a stop. But if the wall is exerting a force on the car, it means that you will have a negative what? You will have a negative F net. Okay. Then 3.2.1, we need to do what there? We need to define the impulse, and we need to define the impulse there for how many marks? For 2 marks. So it says impulse is the product of the net force acting on an object and the time the net force acts on the object. So impulse is the product, impulse is the product of the what? Of the net force acting on an object. So there's your net force, and the what? And the time. So remember the time is represented by what? By the change in time there. The net force acts on the what? On the object. So that is your definition for impulse. And again, remember you need to write your definitions according to what? To the examination guidelines. 3.2.2 says calculate the time taken for the car to do what? For the car to stop. Okay. So what are we going to do there? Using this formula, F net change in time is equals to the change in what? To the change in momentum. So remember, from this formula, what did we say? F net change in time, it represents what? Impulse. And then we said impulse is equal to what? Is equal to the change in what? To the change in momentum. So from there, initially we had calculated the what? We had calculated the data. So it would now be easy for us to calculate. And what do we have on the left hand side? It's F net change in time is equals to what? The change in what? In the momentum. So for F net, what do we have for F net? Remember we said we'll have a negative F net. Why? Because it said that the wall exerted a force on the what? On the car. So therefore our F net will be what? Will be negative. And then for the change in momentum, so remember change in momentum can be represented by PF minus what? Minus P initial. And again we can have what? MV final minus what? Minus V initial. Okay. So we were given a mass of what? We were given a mass of 800 kilograms. So it means that we would then substitute the 800 kilograms there. And then it said that the car comes to a stop. So if the car comes to a stop, we said our final velocity will be what? Our final velocity will be 0. And then the initial velocity VI would be represented by what? Would be represented by the 20. And how did we choose the direction there? It said that traveling at 20 meters per second east. So it means that we are going to decide to say, okay, whatever that is going to travel east, that is to the right, would be what? Would be positive. And then whatever that is going to be traveling, that would be traveling left, would therefore be what? Would therefore be negative. So the 20 meters per second was going in which direction? Was going to the right. And we did not have direction for the what? For the final velocity, because remember it was what? It was 0. So from there you are going to solve this, multiply the 800 into the brackets, and then you would therefore divide both sides by what? By negative 1,6 times 10 to the power of 3. From there you will make change in time the subject of the formula, and you are therefore going to write your what? Your time there in what? In seconds. Okay, so remember, time is what? Time is a scalar. So that is why you are not going to be having what? That is why you are not going to be having the direction. Okay. Then it says the brick wall is covered with a pack of mattresses. So the brick wall is now covered with a pack of mattresses. And the same car, which is still traveling at 20 meters per second, hits the mattress and comes to a what? And comes to a stop. Okay. So the question now says 3.2.3. How will the force of the mattresses on the car compare to the 1,6 times 10 to the power of 3 Newton force exerted by the brick wall on the car? Write only smaller than, greater than, or the same as, and then you need to what? You need to explain your answer. Okay. So answer for 3.2.3 is smaller than, and then how are we going to explain that? So we are going to use this formula here, which says F net change in momentum divided by what? Divided by the change in time. Okay. So the question says, how will the force of the mattress on the car compare to this force exerted by the brick wall on the car? So what is the difference now? What happened? It says the brick wall is covered with a pack of what? Of mattresses. And the same car, which is traveling at 20 meters per second, now hits the mattresses and comes to a stop. So that is the change that we now have. So these mattresses, what are they going to do? The mattresses offers a longer contact time. So longer contact time, there will be an increase in the change of time, in the change in time. And then for the same what? For the same change in momentum. So the change in momentum here is not going to change. And then the longer contact time, the longer the time of contact, the smaller the what? The smaller the force. So I'm repeating, we are saying that if there's an increase, in the what? In the contact time, therefore there will be a what? There will be a decrease in the what? In the net force. So if there's a decrease in the net force, again, remember when we spoke about the injuries, we said that the passenger inside the car would therefore experience what? Would therefore experience less injuries, but that is for what? That is for the same what? That is for the same change in what? Change in momentum. Okay, so this question here is very, very important, and it has a total of what? Of 4 marks. So you would then get a mark there for the smaller than, you would get a mark there for the longer contact time, and you would get a mark for the same change in momentum, and get a mark there for the conclusion there. Okay, and then the next activity here says, the photo below shows a policeman who is target shooting at a range, okay, and then the target with a mass of 1.8 kilogram is moving towards the policeman with a velocity of 2 meters per second, okay. So we have a target here, and then it says this target has a mass of what? Of 1.8 kilograms, and this target is moving towards the policeman with a velocity of 2 meters per second. So we have an initial velocity there of 2 meters per second. And then it says an 8.3 gram bullet leaves the barrel. So we have an 8.3 grams. So that is the mass of the what? That is the mass of the bullet. So for this one, we have a bullet. For this one, we have what? We have the target. And then the bullet has a mass of what? Of 8.3 grams. It says it leaves the barrel of the gun with a velocity of 150 meters per second. So the velocity is 150 meters per second. Then it says the bullet becomes embedded in the target after the what? After the hit. Okay. So looking at the data here, what do we have? We have the mass of the target, we have the initial velocity of the target, and then remember we need to decide on what? We need to decide on the direction. So we can say that the target was moving towards the person here. So we can therefore say that the target was moving due east or to the right. And then we have the mass of the bullet, which is 8.3 what? Grams. So remember, if you have a mass in grams, then you need to divide by 1,000 so that you can convert it to what? To kilograms. And then we have the initial velocity of the bullet, and then it says it's what? It's 150 meters per second. But it says the bullet leaves the barrel of the gun with a velocity of what? Of 150 meters per second. So where is the bullet facing? The bullet is facing in the opposite direction of what? Of the target. So if it's the opposite direction of the target, we can therefore say that the bullet is traveling where? To the left or due west. Okay, so that is the information that we have. 3.1 now says state the principle of conservation of what? Of momentum. Okay, so what do we have there? It says the total linear momentum of an isolated system remains constant or is conserved in magnitude and what? And direction. So again, remember to write your definitions according to what? According to the examination guidelines. Okay, let's have a look at the next one there. So again, we are given the same information, and then now 3.2 says we must calculate the velocity of the bullet and the target after the what? After the collision. 3.3 says determine by calculation whether the collision was elastic or what? Or inelastic. Okay, so learners, for this one, I'm going to give you about 4 minutes. 4 minutes to do this calculations, 3.2 and 3.3, and then we are going to do it together. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay. So let us continue. It says the photo below shows a policeman who is target shooting at a range. Okay, so we saw that previously. Then it says the target with a mass of 1.8 kilograms is moving towards the policeman So we said that that would be our mass for what? For the target, it's 1,8 kilograms. And then this target is moving with a velocity of what? With an initial velocity of 2 meters per second. Then we said we are going to decide on the direction, and then the direction of the target would therefore be to the what? To the right. So if it is to the right, we are therefore going to take the right as what? As positive. Then it says an 8,3 gram bullet. So we have what? We have the bullet which has a mass of 8,3, and then we said that if you have grams, you need to convert it to what? To kilograms. How are you going to convert it to kilograms? It's either you will divide by 1,000 or you will multiply by 10 to the power of what? Of -3. Then it says here an 8,3 bullet leaves the barrel of the gun with a velocity of what? Of 150 meters per second. So that would be the initial velocity of the bullet, and it is 150 meters per second. So we said the bullet is traveling in the opposite direction of what? Of the target. So if the bullet is traveling in the opposite direction of the target, it means that we now have a change in what? A change in direction. So because we have a change in direction, our direction would therefore be to the what? To the left. And then if we took right as positive, it means our left will therefore be what? Will therefore be negative. Then what happens? The bullet becomes embedded in the target after the what? After the hit. So what can we see from here? We do not have the final velocity of the target, and then you also do not have the final velocity of what? Of the bullet. Okay. 3.2 now says calculate the velocity of the bullet and the target after the what? After the collision. So remember, it said what? The bullet becomes embedded in the target. So meaning that they will now have one final velocity. So what is the question asking for? The question is saying we need to calculate the velocity of the bullet and the velocity of what? Of the target after the what? After the collision. Okay. So what are we going to do from here? You are going to write your formula that says the sum of the initial momentum before the collision is equal to the sum of the final momentum, that is when? After the what? After the collision. So you have MI V1I, that would be representing your what? That would be representing your bullet. So remember we said the mass of the bullet is in grams. So it's either you divide by 1,000 or you multiply by 10 to the power of what? Of -3. So in this case here, we divided by what? By 1,000. We divided by 1,000, and then we said in terms of the what? In terms of the velocity, we said we are going to decide on the direction. The target, we said, is going to move to the right. So therefore, we are going to decide that the bullet is therefore moving in which direction? To the left. So if the bullet is moving to the left, it means that we would then have what? We would then have a negative velocity. Then we move on to the mass of the target. The mass of the target was already 1,8 kilograms. So we are therefore not going to convert it again, because we are only converting if we are given a mass of maybe grams or any other unit. So for now, this mass is what? It's kilograms, so we write it as it is. And then our initial velocity for the target was what? Was 2 meters per second, and then we said it is going to be moving in which direction? To the right. Then we said whatever that is moving to the right, we are going to write it as what? In terms of direction, we are going to write it as a positive. So that is why our initial velocity is what? Is +2. So from there, remember the statement said the bullet becomes embedded in the target after the system. So what does that mean? It means that we are going to have a combination of mass 1 and what? And mass 2. So that is a combination of the mass of the target and the mass of what? The mass of the bullet. So this one here, 0,0083, it represents the mass of the bullet, and then the 1,8 represents the mass of what? The mass of the target. So from there we said again, they are going to move together as a unit. So if they move together as a unit, it means that even the final velocity, they are therefore going to have the same final velocity. Okay, so from there, to get your answer, you would multiply whatever that you have on the left hand side. You would also multiply the 1,8 multiply by 2. And then you would add this part with the 1,8 times 2 there. From there you multiply this part here, and then whatever answer that you are going to get, you would therefore divide by that answer on both sides, and that would therefore give you your what? That would therefore give you your final velocity. Okay, so another thing to note is that the velocity is what? Is a vector quantity. So if you have a vector quantity, it means that you need to have, remember vector quantity, it's a physical quantity which has both what? Magnitude. So your answer must have magnitude. What is magnitude? It is the size. So in this case, what is the size of your velocity is 1,30, rounded off there to 2 decimal places. So 1,30. And then you must also have an SI unit. So the SI units of velocity there is meters per second. And then again, the last thing is that you must also have what? You must also have the direction. So therefore in this case, our direction is what? In the direction of the target. Remember we said the direction of the target. In this case we chose what? We said the target would be moving in which direction? To the right. And then we said wherever the direction is moving, which is way to the right, we said if we have a positive answer, that would be indicating to the right. So that is why on this one here, our answer is positive. So therefore our direction, that is why we have it as in the direction of the target. Okay. Then from here, 3.3, it says determine by calculation whether the collision was elastic or the collision was what? Was inelastic. Okay, so it means that you need to understand the meaning of these two words, elastic, and the meaning of what? And the meaning of inelastic. So what did we say about the similarities in terms of elastic and inelastic? Remember we said that the similarities are that the sum of the initial momentum before the collision would be equal to the sum of the final momentum that is after the collision. But what are the differences? We said that the sum of the kinetic energy before the collision, that is for an elastic collision. So the sum of the kinetic energy before the collision is equal to the sum of the kinetic energy after the collision. But then we said when it comes to an inelastic collision, we said the sum of the kinetic energy before the collision is not equal to the sum of the kinetic energy after the what? After the collision. So once you then understand the meaning of these two words, you are then able to answer the what? You are then able to answer the question there. So here we are saying the sum of the kinetic energy before the collision is equals to what? Half mv squared plus by half mv squared. So it means that now you would have to calculate the kinetic energy of what? Of object A plus by the kinetic energy of what? the kinetic energy of object B. So from there we are saying, or the sum of the kinetic energy, from there we are saying half mv squared plus by half mv squared. So you are calculating the kinetic energy for object A and the kinetic energy for object B. So you can then decide which one is your object A and which one is your object B. Okay, so in this case, we are therefore saying half mass. So the 0.0083 is our object A. Object A is represented by what? Is represented by the bullet. So again, remember the mass was what? Was in kilogram, was in grams. So we needed to convert it to what? To kilograms by dividing by what? By 1,000. So we are saying half of the mass. Here's the mass there of the bullet. It's 0.0083 multiplied by the initial velocity. So remember the initial velocity of what? Of the bullet was -150. Why? Because it was the bullet was moving in the opposite direction of the what? Of the target. So we are then going to continue with the very same directions that we used where in 3.2. So from there, so -1,5 squared, and then plus by what? Plus by half. Now we are dealing with what? With object B. What is the mass of object B? The mass of object B is 1,8. And then what was the initial velocity of object B? The initial velocity was 2. So therefore we'll say what? We'll say 2 squared. And that would give us, so you then multiply this portion here. And then after multiplying, you add it to this portion here. So that would therefore give you your answer as 96.98 joules. And then you move on and you calculate your what? You calculate the sum of the kinetic energy after the collision. So again, you are going to use the very same, the sum of the kinetic energy, the sum of the kinetic energy final. So it is the EK of A plus by the EK of B. So again, half mv squared plus by half what? Mv squared. Okay, so in this case it means that you need to use what? You need to use information that you have after the what? After the collision. So what do we know about after the collision? We know that the bullet became embedded into the what? Into the target. So if the bullet became embedded into the target, it means that we are therefore going to have one formula of what? Of half mv or of half m1 plus m2 vf what? Vf squared. So from there, what are we saying? We write our half there. And then, but now what do we have? We have the combination of the masses. So it's the combination of which masses? It's going to be the combination of the 1,8 kilograms plus by the 0.0083. So a combination of the mass of the target and the mass of the what? Of the bullet. Why are we combining the masses? Because we said that they move together as a unit after the collision. So what did we do? From there we have our final velocity there. So final velocity squared. And where are we getting that from? We remember we calculated the final velocity after the what? After the collision. And again, remember we said that we are only going to have one final velocity. Why? Because it says that they become embedded after the what? After the hit. So from there, you would then punch that into your calculator, and the answer would therefore be 1,53 what? Joules for your kinetic energy. So from there, what are we saying? From there we are saying the sum of the kinetic energy initial is not equal to the sum of the kinetic energy after the collision. Therefore the collision was what? Therefore the collision was inelastic. Okay, so you must remember that after calculating, remember the question said determine by calculation whether the collision was elastic or inelastic. So you must remember that after the calculations, you need to give a statement. You cannot just write out the answers and leave them as they are. So you need to give a statement that then concludes. So the conclusion must be based on the sum of what? The kinetic energy before or initial, whether it is equal to or not equal to the sum of the kinetic energy after the collision. So remember we said that if they are not equal, meaning the two answers are not the same, then it means that the collision is what? Is inelastic. But we said that if the two answers are the same, and then it means that we have what? We have an elastic collision. So if the two answers were the same, you would therefore say the sum of the kinetic energy before or initial is equal to the sum of the kinetic energy final or after. Therefore the collision was what? Was elastic. But because now they are not equal, so you therefore say the sum of the kinetic energy before the collision is not equal to the sum of the kinetic energy after the collision. Therefore the collision was what? Was inelastic. So this is very, very important. Remember to always state that statement after the calculations. Okay, then the next one says a 5 kilogram block moving due east with a velocity of 4 meters per second. So we have an illustration here. It is moving due east with a velocity of 4 meters per second. It collides with a 3 kilogram block. So initial velocity, which is moving at 0 meters per second, or it collides with a stationary. So remember, if we have a stationary block, it means that the initial velocity would therefore be what? Would therefore be 0. Then it says immediately after the collision, the 5 kilogram block moves due west. So it is a clear illustration here. This is the information that we have before the collision, and this is the information that we have after the collision. So it says immediately after the collision, the 5 kilogram block is moving where? It's now changing direction. So it's going to be moving due west with a velocity of 0.25 meters per second. And then it says, and the 3 kilogram block moves with a constant velocity due east, as shown in the what? As shown in the diagram. So it says it is going to be moving at a constant velocity. In which direction? Moves with a constant velocity due east. So east in this case would be to the what? Would be to the right. Okay. So now 4.1 says you need to define the term momentum. So what is our definition there? It says momentum is the product of an object's mass and what? And its velocity. So again, the definition there is what? Is 2 marks. And remember, you need to define the momentum according to your examination guidelines. Okay. 4.2, it says which quantity momentum or kinetic energy is conserved during what? Is conserved during this collision. So our answer for that one would therefore be the what? The momentum. Because remember we said the total linear momentum would be conserved during what? During the collision. Okay, so that is just for 1 mark, and that is why we only just needed to state the momentum and not really give what? An explanation there. And the next one then says you need to calculate the velocity of the 3 kilogram block after the what? After the collision. Okay. So remember we said this one is our initial velocity, and this is the mass of the what? This is the mass of the 5 kilogram block. And then this one again, it said it was a stationary block. So stationary block means that the initial velocity would be what? Would be 0. And then this is the mass of the 3 kilogram block. So again, this information is for what? This information is for the before collision, and then this information is for what? Is for after the what? Is for after the collision. Okay. So after the collision, what did it say? It said that the 5 kilogram block, it was moving west. So meaning now there's a change in direction. So this one was moving east or to the right. This one is now moving where? Is now moving west. And then the question now says, calculate the velocity of the 3 kilogram block after the what? After the collision. So that is for 4 marks there. And then 4.4 says you must name and state the law that is used in question 4.3.4. Okay, learners, so for this one, I will be giving you 4 minutes. I will be giving you 4 minutes on this question. So you need to do 4.3 and also do 4.4, and then we are going to do it together. welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us continue. 4.3 says calculate the velocity of the 3 kilogram block after the what? After the collision. So meaning now that we need to calculate this final velocity. So we have the final velocity of the 5 kilogram block, and that velocity is what? Is 0.25 meters per second there. So what are we going to do? Remember, we need to choose direction. So let us choose to the right as what? Let us choose to the right as positive. So that is the initial direction of motion. So initially the 5 kilogram block was moving at 4 meters per second to the right. So we are going to choose the right as positive. And then for the initial velocity of the 3 kilogram block, we had a 0 there. After the collision, the 5 kilogram block was moving in which direction? It was moving to the left. So because it was moving to the left, and we said that for the initial direction of motion, we are going to choose that as positive. It means that for whatever that is going to be moving in which direction to the left, we are going to write that as a what? As a negative. So what are you going to do? You firstly write your formula. The sum of the initial momentum is equal to the sum of the final momentum. And then you break down your formula to say the momentum of object A plus by the momentum of object B is equal to the momentum of object A plus by the momentum of what? Of object B. So what is the mass of object A? The mass of object A, remember, was what? Was 5 kilograms. What is the initial velocity? It was what? It was 4 meters per second. In which direction? We said whatever that is going to the right, we are going to write it as a positive. So that is why we have what? That is why we have a positive 4. And then the mass of the second object was what? Was a 3 kilogram. And then what was the initial velocity? Remember, they said it was stationary. So therefore the initial velocity would be what? Would be 0. Okay. So from here you can immediately see that the 3 times the 0 would therefore give you a what? Would therefore give you a 0. And then after the collision, what happened? You write the mass of object A, which is what? 5 kilograms. After the collision, this block was moving to the left at what velocity? 0.25 meters per second. So why are we having a negative? So remember, we said whatever that will be going to the left, we are going to write it as what? As negative, plus by the mass of what? Plus by the mass of object B. So the mass of object B is what? It was a 3 there. And then what are we calculating? The question said that we need to calculate the final velocity after the what? After the collision. So what are you going to do? You would then multiply these two. You would then multiply that as well. And then from there, you are then going to transpose this one to the other side. Then whatever answer that you have, you divide on both sides by what? By the 3. From there, that would then give you your final velocity. So remember, we said that if we are going to get a positive answer, our positive answer will be indicating what? It would be indicating east or to the what? Or to the right. So with the answer, again, because velocity is a vector quantity, it means that you would have to have magnitude. So the magnitude is what? Is 7.08. You would need to have an SI unit, which is meters per second, and then you would also need to have what? You would also need to have the direction, which is what? Which is east in this case. 4.4, it says you must name and state the law that is used where in question 4.3 above for how many marks? For 3 marks there. Okay. That law is what? It is the law of conservation of momentum. And then it says the law of conservation of momentum in a closed system remains what? Remains constant. Okay. So that would therefore be for how many marks? For 3 marks. So the next one here says a bowler bowls 100 gram cricket ball to a batsman. A 100-gram cricket ball to a batsman. The ball approaches the bat with a constant velocity of 40 meters per second. Okay, so the ball is approaching the batsman with an initial velocity of what? Of 40 meters per second. And then it says the bat strikes the ball. So the bat is striking the ball back towards the bowler at a velocity of what? At a velocity of what? Of 50 meters per second. Then again 3.1, define the term momentum in words. So it would be the momentum is the product of an object's mass and its velocity. So again, remember this one, you need to define it according to the what? According to the examination guidelines. And then 3.2, it says you need to calculate the change in the momentum of the what? The change in the momentum of the ball. Okay, so that is for what? That is for 3 marks there. So what are you going to do there? You are going to write your formula, which says the change in momentum would be what? So the change in momentum would be P final minus what? Minus P initial. And then for your P final, you have MVF minus P initial. PI, you have MVI. So from there, what do you have? Again, you can write, sorry about that. So you can write the V final and the V initial inside the brackets. So from there, what are you going to do? In terms of the collection of data there, we have 100-gram mass. So our mass there is 100 grams. So what is the first thing that you are going to do there? You are going to convert this mass, which is in grams, to what? To kilograms. So how do you convert to kilograms? You are therefore going to divide by 1,000, or you can multiply with what? With 10 to the power of what? Of -3. So in this case, we divided the mass by 1,000, and then it therefore means that our answer there is 0, what? 0,1. And then from there we need to decide on what? We need to decide on the direction, right? So we have taken the initial direction of motion as what? The initial direction of motion as positive. So for the 40 meters per second there, the direction is positive. And then therefore for the final velocity to the right is therefore what? Is therefore negative. So what are we going to do? We then substitute our final velocity. So final velocity with a -50 there, and then we substitute our initial velocity. So you punch that into your calculator, and then it would give you a -9 kilogram meters per second of the change in momentum. So remember, with the change in momentum, you are also going to write the what? The direction. So remember again, the change in momentum is a vector quantity, so therefore it means that you would need what? The magnitude, which is 9, you would need the SI unit, and also you are going to write your what? You are also going to write your direction. Okay. So, okay, learners, we have run out of time, so I will just give you this one to do as a homework. 3.3, so you can maybe take a screenshot of the question as your homework. And then from there, I'm going to leave you with the words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." Thank you so much, learners. I will see you next time and at the same place. Thank you.